Hey everyone, I'm Brooks. This is the Remix Austin Meetup for those who are maybe new, or even for those who aren't new. It's still good to know where you are. Thanks for everyone for coming out. Yeah, if you're watching the recording of this, it is like in the 40s in April in Texas, which is pretty bizarre and unheard of. And it's been raining all day. So I am impressed. People showed up and very appreciative people showed up. I was saying right before we started recording, I think we have more people online than we do in person, which has never happened in this group. But makes me happy that we have the online presence. So if only they're away, we could send you virtual pizza. But, alas, you'll have to come in person next time. But yeah, happy to see everyone here. Like I said, this is the Remix Austin Meetup. It's a monthly meetup. We are shifting to the first Thursday of every month. So log that in your brain if you want to keep coming. Yeah, it's a place to talk about really web development in general. Specifically, we talk about Remix, which is a pretty cool web framework that, that's kind of what brought us all here together. But the thing that at least I like a lot about Remix is that it really tries to build on top of what's really good about the web as a whole. And so that means that we get talks about all sorts of things. Like tonight we're talking about cache headers. That has nothing necessarily to do with Remix specifically, but the way that does interact with Remix is pretty cool. And we're talking about building a 2FA, two-factor authentication form, which you do in lots of different websites, but we'll maybe see the specific way you can do it in your web framework, such as Remix. Like I said, we got Will, zooming in from Alabama, right, Will? Did I make that up?
Yep, Montgomery, Alabama.
Montgomery, Alabama, which is the birthplace of the civil rights movement. Also, where my mother's from. So fun facts all around. Anyway, he's going to be showing us how to build a 2FA wizard in Remix. So I'm super excited to see that. And then Colby White, who is here in person, is going to be showing us some caching basics with Remix. So yeah, that's what we got on the agenda tonight. And just a quick plug, if you have talk ideas, I know there's a question on there about if you're interested in giving a talk. This is just kind of a general list of a bunch of stuff you can talk about, but there's no limit. It's the web. Like, if you can do it in the web, you can do it in Remix. You can do it in Remix, you can do it without Remix, but Remix just might make it a lot easier. So yeah, that's the deal. So if you have an idea, definitely feel free to talk to me. I think I already have 2 speakers already signed up for next month, so it might not even be till June, but still, gives you plenty of time to work on your slides. All right. With that being said, I'm going to pass it over to Will.
Awesome. Thanks, Brooks. And thanks for letting me do this. Even though I'm not in town, I'm pretty excited about this. I was demoing this earlier today, taking a practice run at work, and did not meet the 20 to 30-minute deadline that you gave us. So there was a lot of last minute condensing. So just as a heads up, as I'm going through kind of more of the code and kind of like the code and schema parts of the app, I've kind of took out a lot of details that were not necessarily important to the bigger concepts that I want to cover to try and move a little quicker through all this. But I've got the repo that I'm going to share at the end that has all the code, all the details that you'll want. So y'all can poke around there and feel free to ask me any questions in the Remix Discord whenever this is over or anytime in the future. So my name's Will King. I write about Remix as well as other software and product topics over at WKing Dev. And tonight I want to share some of the learnings that I had implementing multi-factor authentication in Remix. We recently did this at work, just kind of working with our API team. And then I wanted to kind of take it all the way to the back end and explore what that'd be in Remix from front all the way to the back. So, like I said, my name's Will King, but I work at just a little more detail. I work at Crunchy Data as a senior front-end engineer. And my job there is to help build the best Postgres experience on the web. We're a managed Postgres provider. And with the goal of building the best experience of anything on the web, it was a no-brainer last year to migrate to Remix. So we are fully on Remix for both our app and our main website, marketing website. And it has just been great to work in that. The title of the talk makes it pretty clear what we're going to be discussing. But instead of just digging into technical details, I also want to dig a little deeper and talk a lot about how to go about building something, planning something, kind of the product process as well as the technical details. So we got 3 goals. for this talk, we're going to understand what we are building, and a lot of times, more importantly, what we're not building. I want to show how good data and Remix make building systems a breeze. This tweet by Mark kind of really hit the nail on the head for me about why I've loved Remix so much, specifically the second paragraph. The second paragraph says that the aha moment for Remix was it takes the simplicity of server-side state management to the client. And I think this is especially true, and I try to point it out in a couple of places in this talk. And then the final thing is we're going to be focusing on a very narrow part of building a multi-factor authentication system. However, there are obviously a lot of supporting features that you'll need to build for production. So we'll kind of go over those at the very end. UI is flexible, databases are not. It's a bit hyperbolic, but not that much if you're familiar with both. Obviously, databases, there are some changes and migrations that are not that scary, but there are also some that are just a nightmare to deal with, especially at scale. And then in general, data model changes are like the most brittle things to break an app without trying to factor in a lot of like backwards compatibility. UI is a lot more flexible in that sense. There are obviously places where UI can get brittle, but this is an important kind of principle that I think about, especially since working at Crunchy Data and working with all those huge database nerds that know a lot more than I do, that databases are generally a lot more difficult to change. UI is not. So just we're going to keep that in mind as we're going to talk through some of these features of what we are building and what we're not. So what we are building is specifically setup for TOTP support for multi-factor authentication. There are lots of different multi-factor options. We're going to focus on one, and this is generally how we do it on our team in the front end in the real world too. We focus on one part of a system and really scope it down so we can keep momentum moving, keep PRs small, and try to build systems behind feature flags that are easy to ship, easy to review, to guarantee are working, and then be able to integrate them as we ship more and more features of the system to then make it ready for deploy. So that's what we're going to be doing tonight as well. With that in mind, you're planning short term with these type of things where you know a lot more, but you also want to think long term. Now, I've never seen it. It's extremely rare where you can think of every use case a feature is going to have in the future, but you generally know the direction. So in our case, we know that web auth-in, maybe SMS, like other methods will be added. So since our data model is harder to change, we want to make sure that we're accounting for that flexibility up front. Time limit on setup is a security thing. We only want to give people 10 minutes to try to move through the setup process. If it's any longer than that, it could lead to, any type of public browsing session. Those details could be left there for people to log in and lock you out of your system. So we're going to keep it short. Expiring authentication on a user session is how we're going to manage challenging people as they do app actions across the app. So once you're set up, we're going to have a rolling expiration for the authentication. So like every 5 to 10 minutes, if you do an action and you haven't verified your two-factor authentication and you're doing a sensitive action, it's going to ask you for that again. But it's not going to ask you too often because that would be terrible UX and very frustrating. Another UX concern is we're generating recovery codes before the actual setup of two-factor authentication. It's because, browsers as well as your app can be brittle at times. So if the browser fails or your app fails and they've already activated their two-factor authentication, but they have not gotten their recovery codes yet, that could be a not great situation. So we want to guarantee users get recovery codes before it gets activated. And then finally, we're going to do setup for TOTP. If y'all are familiar with it, if you're not, we'll go through it. It's done using a QR code. If the device that they're using doesn't have image capabilities for QR codes, there's a fallback as well, which we'll cover. So with that in mind, before we dig into our data model, I'm going to take a quick break from the screen sharing of the slides. I'm going to show you real quick kind of what we're building. Can everybody see this screen here? So this is the actual application for the repo that I'll be sharing. And I'm just going to walk through quickly what this workflow will be, just so we all have an idea in mind as we're talking about the data and we talk about the different steps throughout this. You'll be able to kind of piece it together in a bigger picture. So in the settings, we're going to enable multi-factor authentication. We have this download page that just does nothing other than just render HTML, which I love about Remix, how easy it is to just put a route out with that type of stuff on it. As well as a couple options for apps that you can use. Next, we're going to move to our recovery codes. It generates our recovery codes for you. You can copy the recovery codes as you hover over it. One thing we're going to cover here in a minute with our data is the security codes can only be viewed when they're created. Once they're created, they're gone forever. We'll talk about why. So this page also has a state where we need to reset our recovery codes if we didn't get them, and they're gone, like if your browser reloads for whatever reason. So that just generates new codes for us. And then finally, the last step is the actual setup for the authentication. I'm just going to do that super quick. Like I said, the code for this is going to be in the repo. This input field was a lot of fun to build, but has nothing to do with some of the important details that we're going to cover in this talk. Like I said, there's a QR code, and there's if you're having issues, there's this little backup window where you can grab the secret directly to set up the multi-factor authentication with the app that you're using. And that's it. We're set up. This is the flow that we're going to talk about tonight. So let's dig into our data model. So specifically, these features apply to the data model. Now, the time limit on setup and the expiring authentication session at Crunchy Data are data problems as well, because we integrate with an API, and the API is the single source of truth. But when you get to run a Remix project where the Remix repo has database, server, and client, you get to push these other factors to another part to where your data model can be a lot more generic and a little easier to work with, because those things can be handled elsewhere. So with our data, one thing that we are going to keep in mind is the idea that we're only focused on TOTP, but there are going to be additional methods in the future. So with there being additional methods in the future, we need to account for normalized data. So in this case, there's a table that is the single source of truth, and then there's a specific table that stores more customized data for each. Questions that kind of lead me to this type of architecture is, when you're working on this feature, how can you tell if a user has multi-factor authentication enabled? How do we know which ones are enabled and which ones are not? How do we account for methods having different data requirements? This type of architecture allows us to do that. This normalized table is only going to contain all of our methods, the common data, and it's only going to exist in this table if it's enabled. So by running a single query against this table without any joins, we'll be able to pull all of that, and also we'll be able to not have to worry about pulling sensitive data from our specific tables. We can just kind of get a generalized idea of what's enabled and what's not. We can also store common data. So if you want to name some of these methods, or you want to be able to set a default. So let's say we add this TOTP and SMS and email. Which one does the user want to do by default? That can be something that's stored on a normalized table. And then we have our specific table, which every data model is different. So TOTP only has a secret that's stored in the database, but SMS is going to have secret and a phone number. WebAuthn needs like 4 different things that I'm not going to dive into. It was a blast working with it. A blast like most things that make you want to beat your head against the wall. But as we move on to the database table here, I want to show just kind of like what the shape of it is, just so y'all kind of have an idea of what the data is going to look like. In the code base, there's a Prisma schema file with a lot more detail about this. But at a minimum, you'll have your users table. Even if the site has accounts or teams, multi-factor authentication is something that's very specific to each user. So it's going to be attached to users. We're going to have a multi-factor table with all of our multi-factors with the method identified on the table. And this is going to be a many to one relationship on users. We have multi-factor TOTP. That's going to be a many. This is only going to be you only have one TOTP authentication. So there's going to be one record. It's a one-to-one relationship with users, and it's a one-to-one relationship with our multi-factor table. And then we have recovery codes where we're storing a hash of what those codes are. Hashing is, before diving into this, I didn't do a lot of encryption or hashing and didn't know that there's a difference, and learned a lot doing that. So hashing is when you change a string like a password or a one-time code, and it can't be unchanged. You can compare it using bcrypt and other tools, but it's different than encryption where you can unencrypt it. Hashes are a lot more secure to any type of like security vulnerabilities, because it's unencryptable. But that also means that we can't then show users their secret anymore because we don't even know how to detangle it. So that plays into our UX a little later on. As we covered, this is the download page. I'm not going to go into any details on this because it's just HTML, which is great, which is why one of the great things about Remix is you don't have to have a complicated web page for it to be awesome. This page was super easy to implement, great with React, but there's not necessarily any like big architectural details other than it was great to build. The next page that we're going to dive into is the recovery codes. So as I specified, these codes are getting hashed when they're created, and when they're done being created and stored in the database, we can't unencrypt them to show the user again. This means that when the person loads the page, we check to see if they have recovery codes, if the page refreshed for whatever reason, and we prompt them if they want to reset their recovery codes or keep going, because they might have already saved them. We don't want to blow away and automatically regenerate the recovery codes, so we just prompt them to reset them manually themselves. So let's walk through the loader, our UI, and our action. When we're displaying a UI that has different states, my favorite method is to use a union type, as we do here. I learned this back in my days of when I coded a lot more Elm, from Richard Feldman. I'm going to share a talk name. It's Impossible, Making Impossible States Impossible. Y'all might have heard it from like a bunch of different sources. That talk is one of my favorite talks and really helped my development career in terms of thinking about how to structure and manage code and state. So what you can see here is our loader data is basically in two states, existing or new, where only new has actual recovery codes attached to it. So we make sure that the user exists on the session. We check to see if the codes exist or not. If they exist, send back that state. If they don't exist, we're going to generate them using the user email as a salt to make sure that there's no collisions with the generated codes with other users that might be generating codes. Save them to the database, and then return our new state with our recovery codes. Once we get to the UI, my favorite way to handle, like the reason why I love union type so much is like it's so easy, especially with TypeScript, to just switch on our available states. So you can see here, there's the page component that has the idea of like just the UI parts, like panel. There's a button that's just a link to the next page. And then there's this body where we're switching on if it's existing or if it's new. If it's the new, we're going to list our backup codes. It's all just Remix, nothing really that special there. So I want to just kind of focus on this part of Remix, which is like, this is all that's needed to submit an action. It's just a form on the page. And then just to sprinkle in a little UX niceness, we can use navigation and match on the state. If the request is currently idle, then we show the reset recovery codes. But if there's a request in progress, navigation state will not be idle, and we can show that it's currently trying to reset the codes. Once that form's submitted, this action is what handles it. We delete the recovery codes and we just redirect back to the same page. Now, this is one of my favorite parts about Remix and what that Mark was talking about, which is there is no going back to your component and having a use effect hook that checks to see if that data has changed and then to re-render based on different state. I redirect back to the page, and that loader that we covered a couple slides ago just reruns, checks if there's anything existing. If there's not, it creates new ones. And like that is it. It is such a great cycle where our state is what exists in the database, and Remix does a great job of handling the abstraction of keeping those load times fast, running them using JavaScript behind the scenes, or falling back to not JavaScript ways of doing it, and it's still working. So it's just like this page was so easy for something that has like multiple states for the UI and is going to be deleting and trying to change data on the page. It really comes down to like not a lot, as you can see. So just really great experience for that page. As we move on to the setup page, this one starts getting a little more complex, but it has one of my favorite parts, which is those other three features we handled at the data layer. We would have had to handle some of these features not at the data layer, if we're working with an external API. But with Remix, we can handle these with our user session, and with other types of sessions or cookies, because there's this concept when you're setting up authentication where you've started to create a record. You generate this secret, and there's this in progress place where you've generated a secret. You need to be able to reference that secret in the action. And we'll get there in just a second. But in Remix, this can all be handled without having to push this to your data layer. So this is the page just for reference again. Here are some helpers that we need to keep. I wanted to show y'all before we dive into the loader UI and the action. This is what our user session will look like now. It's another union type, surprise. There's basic authentication, which is just the user ID. And then we have multi-factor authentication, which keeps track of the user ID, as well as this expires that we're talking about, that we will use to create that rolling check on if an action action needs to be challenged using their multi-factor authentication method, depending on the date. This TOTP is a cookie, and this is like part that I love. In a database, you'd have to set an expires at. You'd have to run some sort of cron job that checks to make sure that new in progress data gets deleted periodically. Because we're doing this all in session, we can just all in Remix. We can do this using a session or a cookie, and the max age allows us to set when it just gets deleted without us having to do anything. So this is set to 10 minutes. And that's just this part of the platform that allows us to set these expiring pieces of data that we may need to set up in a loader and reference in an action, but it's going to be recycled for us automatically if it's just left there a certain amount of time. And then finally, there's this other helper for validating our data that we expect to be stored in the cookie. I like to do this just because I'm a types guy. I also like to make sure like validations are great. So like runtime validation, this allows us to check, is what's in this cookie actually what we expect it to be? Let's just verify that before we move on. So you'll see this in action here in the loader. Once again, we're just checking to make sure there's a user that exists and getting it. We look, in this line, we're pulling the cookie, we're using the validator to see if it exists. If the cookie does not exist, then we're going to generate the secret, make our QR code, and send this back. Our data is the QR code and the secret. And then in this case, if our cookie doesn't exist yet, we need to go ahead and set it. If it already exists, we don't want to reset it and change the date on the cookie. So what we're doing is we just skip the headers part of it. We're pulling the existing secret from that data and then generating the QR code and sending that back without changing headers. Once again, very pared down from what is there, but it kind of captures the important parts here. We get our QR code and the secret from the loader data. We use our navigation state once again to just make a little better UX for buttons for our users. And then we have our form. And what I want to point out here is this another great part of the platform. We have two submit buttons. We have the validate submit, and then we have our cancel button. Now, in the other pages, there was a cancel button, and the cancel button just navigated you back to the settings page. But in this case, there's some actions that we need to handle if we're canceling to, we're just going to handle just getting rid of that session automatically, just so it gets remade the next time that they're coming in. You know, technically, because it expires, you could skip this and just make it a link, but I wanted to use this as a chance to kind of show y'all a little extra feature that I love as part of Remix. So once this form is submitted, whether it's submit or cancel, we'll walk through the cancel workflow first. This is our action. There are lots of ways to handle actions with multiple actions on the page. This one, since it's not two separate forms, but instead is a single form with different data submitted, what we're doing is we're checking to see if the form data has the cancel. So when we click this button, if you click the regular submit button, this value on form data of cancel with a value of true does not exist. It just isn't added. But if you click this submit button, that gets added to your form data. So we can check to see if cancel is in the form data as a key. And if it is, we know that that's the action that we're handling. Otherwise, we're going to handle our verify action. So this is our cancel action. Just real quick, we're setting our cookie. We're just going to nullify the secret. And then by setting the max age to -1, it will basically like delete the cookie for us as that cycles through the request. This is the verify action is two different chunks. This is the first chunk where we're just doing some validations. First, we're checking to make sure that the token actually got submitted. If not, return whatever error you want. I was going to dig into some return error stuff, but once again, for time purposes, I'm going to skip past that. I'm going to share an article at the end in case you want to dig into one of the error handling things that we do at Crunchy Data that I was going to share. That article walks through it pretty well. We use that same validator to just check our cookie because we have to have that secret to compare our code, the token that we're getting from the client. If that does not exist, we have to return an error because without a secret, we can't do any of our validations. So then we get the secret. We check to see if that token and the secret match using the OTP lib. If it's not valid, return an error. And then if it is valid, where our validations are above this, we're going to move on to like saving everything and activating. So it only gets saved to the database at this point. That way, if anything errors out before this, there is no record in the database of any multi-factor authentication being set up for this user. That is how we handle it here. We save this to the database. Then we're going to set some headers. The first thing we want to do is nullify our existing temporary TOTP cookie that we've been using for this page. Then we want to go ahead and update our user session because they're no longer going to be basic. And if they have other multi-factor authentication methods later on, then we want to go ahead and do this so that we can update their expires at. So the kind multi-factor expires is in 5 minutes. This could be to however long that you want it. And then we store the user ID. And then we're going to go ahead and commit that to our session. And then finally, we're going to redirect back to our settings page with those headers involved, so that those are saved and we can move on. If there's an error saving things to the database, we're going to catch that and move on from there. All right. That is the workflow. There's when you're looking at it in the repo, there's really not that much to it for something that is so complicated because Remix just makes the state management for this so easy. The components are very, very concise. They're only worried about the data that's sent in. They're not making requests out to other things. We're just working with data that delivered to the client. It's such a great experience compared to past React framework experiences that I've had. So let's just cover over some of these. If you're going to ship this to production, what we would generally do is ship just the setup. Behind a feature flag, we know that this system works. There's not any challenges. Those will be added later. That's a very important part. Once their session can be identified as multi-factor and they have an expires at, we need to start building that into actions that are important, like login, password change, whatever things you consider worth validating their multi-factor for after the expires, that gets built into the system. Onboarding, whenever somebody creates a new account, you need to be able to like show them this page that says, if you just created your account, do you want to enable this? If not, skip. We're going to add WebAuthn. That's just a really convenient thing to add. That's like Touch ID, or if you have, what are they called? They're like the little USB things that you touch. YubiKey, that's what it is. Those kind of fall under this WebAuthn umbrella. We want to allow people to disable multi-factor, and this comes after the multi-factor challenges, because you need to be able to challenge them with their multi-factor challenge before allowing them to disable it, so people just can't come in and disable. We want people to reconfigure it. If for some reason they're like losing their device, they lost their device, they can use a backup code to reconfigure it. And then there's also like recovery code tools, like being able to, once you start using your recovery codes, you can't use them again, so you need ways to regenerate them. These are all things that are going to be important if you're pushing something like this to production, to roll out, to have like a fully working system. That's it. That was a lot. Here are some links. Obviously, it's a slide, so if you want to follow me on Twitter at wking__ or in the Discord, I'm going to try and share some of these links so you can actually go to them. But if you just look at wking-io remix multifactor, that's the repo, wking.dev in the library, you'll find Keyed Flash, which is one of our error handling strategies at Crunchy Data, as well as the button article that kind of talks about like the buttons I used across the app. Make Impossible States Impossible by Richard Feldman. Fantastic YouTube video. If you haven't seen it, you need to. It's really awesome. There's my Twitter. Coming soon, I'm going to write this up in a blog post, as well as the multi-factor challenge and like the replay. Like when you challenge a request, good UX is to not force them to like resubmit the form again. You just automatically submit it for them. So that will be coming soon. And then I want to cover WebAuthn support as well, because it's kind of a little bit of a pain to deal with. So I think an article is needed along those lines as well. But that's everything. A little bit more about me. This is my awesome family. Thank y'all for listening. I hope y'all were able to get something from this. Maybe if I had to go through a lot of it quick, you'll be able to watch the recording back and maybe slow me down or review some parts. But yeah, that's it. I hope y'all enjoyed and got something out of this.
Sweet. Any questions for Will?
Yeah, happy to answer them.
Go for it.
So before you picked Remix, how complex would this feature, how would the implementation look?
So that it kind of, I guess it kind of depends. But I think a lot of times something like this would be put into like a single page. Like a lot of times it would be done using like what I might have done before would be to have like state for a page, some kind of global state, and I would be tracking, kind of like what step they're on, because things aren't happening in loaders and actions. They're all just client-side requests kind of going out. And so what I'd probably end up doing is have some more complicated state with like use effects and things that track when requests change to show the next step of the form. But this Remix model just really forces me to kind of break out of like what is the like client only way and like really leverage the server part of it and like go through that full request cycle to really kind of like it's like I said at that Mark tweet, like it really simplifies state by pushing off actions to the server that are better handled there.
Oh, and I wanted to piggyback off of what you were saying. Like, I didn't see a single, there's no use for a use effect, and I didn't see any use memos because it's all server-side rendered.
Yep. Now, if you look in the code, there's I think a use callback specifically just for the copying the code. So that we can like check to make sure that the window exists for the window.navigator. But like if you don't add copying things to the clipboard, yeah, like there's no need for like use effects or complicated um, client-side state management. Now, that's not to say that Remix doesn't have cases where that is needed, but it just means that like the times that you do end up reaching for that, it's because like you actually have the use case for it, not because you're just defaulting to it.
Got it. Thanks.
Yeah, absolutely.
Sweet. Any more questions online or in person?
You said you migrated to Remix. What'd you migrate from?
So it used to be in a Next.js app 2 years ago before I started working there. Then they migrated to like an Express with a handwritten remix thing that actually allowed them to move a lot faster, just because it removed a lot of cruft. I think that with like, it basically was like a remix without the remix. They really wanted to handle server side and client separately at the company, and they moved a lot quicker that way. And then when I came in, I was very into remix, and I was like, y'all basically got like a not remix. We started running into like growing pains with like having to hydrate certain things. And I was like, guys, like, I think remix is what we need. And they were all kind of thinking it too. Like the rest of the team was starting to get into remix too. We used it as like a test project on our marketing site, and everybody was just like, let's do it. So there's still some fun parts in Express that we've yet to detangle to move over. But all of our routes are over there. There's just some like middlewares that are yet to be pushed over.
So yeah, online question from Seth. Said unrelated to two-factor authentication. How'd you style your application? He super digs the design system.
So I use Tailwind. I actually have a background in design. I was a designer before I was a developer, and then I was like, I want to be able to build what I design. And so like Tailwind was like everything that I wanted, because it gave me the tools to like move quickly and set up systems, but it allowed me to kind of like do what I wanted with it. So I used Tailwind with just like some fun stuff. I was like, I don't have to make something that looks businessy, so I'm gonna just have some fun with it. So, icons I grabbed are from StreamlineHQ.com. If you're ever looking, they have like fantastic. I think this is it. I hope that doesn't lead somewhere else, but Streamline HQ. Yeah, perfect. Thanks, Brooks. So they have like illustrations, icons. They're fantastic. Bunch of different styles. I love using them. Like I use them a lot for like empty states in UI. So
Seth, to get this design system and style, you I think just have to hire Will. Was the answer?
or you could just look at the repo too. There's plenty of details there. I've always kind of enjoyed this kind of like retro-y video gamey type style with a lot of things that I do.
Yeah, for sure.
Steal away.
That's the open source software way, isn't it? So
I can grab that repo link for you real quick.
That's great. And then we can post it on the meetup afterwards as well. And then I'll put it in the YouTube recording of this as well. So we'll get it as many places as we possibly can.
Awesome. Appreciate it.
Cool. Well, thanks so much, Will. Another round of
absolutely.
lots of things to do.
Thank you. I may be dropping off to help with kids' bedtime, but hopefully I'll be back on.
No, you're totally good. That's fine.
Because I also want to learn about some cache headers.
Cool. If you miss any of it, it will be recorded, uploaded either tomorrow or Monday, depending on how lazy I am.
Awesome.
Cool.
Appreciate it, everybody. Y'all have fun.
Thank you, Will.
Well, sweet gang. Quick introduction to me. I'm Colby. See, I've been doing this 13 years now. At various places, I've been full stack my whole career. I think in my first job, I didn't even realize there was a front end and a back end. So I was just so naive and dumb. So I just did it all. And thus, the last 5 years of this whole full stack framework regeneration has been music to my ears. Number one so far, it's obviously been Remix for me. I'll kind of restate what Brooks said, right? Philosophically, Remix is taking stuff that's been around the web for years, decades, and just wait for it, remixing it. I also like it because it's got an apt name. So in that vein, we're gonna talk about something that has been in the web for who knows how long. It's cache control headers. I've known about them for a long time, never used them. using the remix kind of gave me I saw an opportunity to use them for some cases. So I was like, all right, let me actually learn this thing a little bit. And here we are. So what I'm gonna do is we're gonna talk cash control, which, that part of the talk is not really gonna be remix specific. And we'll kind of tie it into remix. And then we're gonna play a game. I'm gonna throw a little quiz to make sure you're all paying attention. If you win, you get a VIA 313 piece of sauce. I'll be quizzed too, because I made these slides like a month ago and I legitimately don't remember what the questions were. So first, let's talk some context and talk about rendering. Right. So the kind of three main styles of rendering to keep in mind, big ones at least. Well, first, client-side rendering. This has been the SPA world for the last decade or whatever. So you put your JavaScript, you bundle, you do your React build tool, whatever your build tool of choice is, bundle it all up, put it on a CDN or something. Network request comes in, you return a whole boatload of JavaScript. When you're not returning any little to none HTML, right? So like visually, there's actually for a split second, nothing on the page. Typically, most people put like a loading icon or something, but you have very little HTML, there's very little render, and then you run the JavaScript, and that's how you get HTML and CSS. So that's the standard SPA way, standard client-side render. We've got some pros, cons, right? Pros, it's easier to do user-specific content because you're rendering on the client. So anything specific to the client, you can factor that in. Because it's all JavaScript, you can make it very interactive. This is kind of what kind of led the industry towards this in the first place, was that interactivity. Cons, lots of JavaScript. Your SEO probably sucks because that initial hit, is nothing. There's no HTML there. And then you end up with a lot of loading icons. Loading icons of death. So let's move to static site generators. There's been over the last decade, a resurgence of these. This is where we are going to render the website at build time. So at build time, we're going to run some tool. There's a gazillion of them out there, right? So let's just say we're using Gatsby or something. We're going to run Gatsby. Gatsby's going to make all the network calls, do all the things for us. And then on our file system, just spit out some HTML, CSS. We throw that in a CDN somewhere. And now at runtime, network request comes in. There's no JavaScript to run in theory. Sometimes there's a little bit, but it's very little. You just get the HTML, boom, and you're rendered. Pros, very fast, right? We don't have to run JavaScript. Because there's little to no JavaScript, little to no security risk. It's very simple. Your SEO is going to be better because you've already rendered the page. So there's a lot of pros there. The cons is your builds might take forever, right? Because every build might have to make several network requests or hit a database and all that good stuff. Another big con is you're just returning HTML, so it's going to be static, right? So typically this is good for like a marketing website that doesn't change very often. Maybe like a form that's always the same or something. So typically used for static sites, hence the name static site generator. Let's talk about what I hope is everybody in this room's favorite style, and that's server-side rendering. So what does this do here? We're going to make a network request to a server. The server is going to run some code. This little step is I purposely put very abstract, right? Because it's going to depend on your framework, what's going on there, but you're effectively running code. That code is going to build some HTML, CSS, and then return that to the client. So as opposed to, we go back a couple slides here, right? Where we are running the JavaScript on the client in order to get the HTML. Back in server-side rendering, we're running the code. It's not necessarily JavaScript first and foremost. It's whatever we want on the server, right? So we have more flexibility there, but we're running it here with a big beefy server box, as opposed to the client, which might be like a mobile phone in the middle of nobody, right? So we got better performance there. That's a big pro here, because now you got a big beefy server involved. Little to no JavaScript, right? You have an opportunity to just return static. And because we're returning static, we got great search engine stuff. Big con, you got a server involved. Right? This is a big reason why people, or one reason why people like the SPA. One argument for it is no servers, right? Now you got to maintain that server, all that good stuff. Then interactions, right? Your interactivity is going to be a little minimal. Also, when you're doing page navigations, right, you're typically going to another route, which is another hit to our server. That's effectively a full page reload. So you've traded in loading icons for full page reloads. So pros and cons, every situation has its preferred style. So that's context there. So now let's talk about caching. This is a very high level because caching is one of the most complicated things in the world. So not going to go deep here. We're just trying to get enough context here so we can have this combo. Two main topics that I want to talk about here. So first, let's talk about browser caching. This is a screenshot of my, I think that's Firefox debugger. What am I think I was going to ESPN.com here, right? These are some icons or whatever for all the teams. And you can see here, it's all cached. And it's cached on my browser. So I think it was on my laptop. So like my browser, I'd already been to ESPN.com. I go there all the time. Is like, I know what the Detroit Pistons logo is. I got it here. I'm not going to go make another web request. So obviously that's a lot faster because it's just all stored there in memory. So that's at the browser level. Now let's talk about the CDN. So the CDN, for those who aren't familiar with the CDN, content delivery network. I'm glad I put that there. What we got here at CDN is we have all these nodes scattered across the world, right? So they've got Cloudflare, Vercel, Netlify, AWS has one. I forget what theirs is called. There's a bunch of these out there. When all of them are doing is taking servers / nodes, scattering them across the globe. So now if I'm in Australia, so we should compare it to the classic, right? So let's say, I have my website, I put my server over here in Austin, Texas. Someone from Australia hits my website. That's a network request that's got to go travel across the globe. I guess it would actually travel the other way. But either way, that's going to take a while. So CDN scatters these nodes across, right? So now when I deploy my site, I'm not deploying it to one server in Austin. I'm deploying it, it gets deployed across all these nodes. And the CDN is smart enough to say, okay, we got a user from Australia. We're going to serve it to them from the Australia node, whatever's closest, right? So this is real good for those static websites we talked about, right? Because it's just a static HTML file, doesn't change. Copy paste that bad boy across the globe. Don't talk to me, just serve it to them. So, but what effectively this is a cache, right? So I'm caching this across the node, right? What happens if I change it? Now I got to go update all my nodes in my cache. So it's one of the key here is that this is a fancy smancy cache. All right, so let's combine those two concepts: caching, server-side rendering. All right, so here's the standard flow. So for server-side rendering with no caching, I think this is what this is. Client comes in, so we got a little snail here, right? Because it's going to take a while to hit the server. Server's got to run and return a thing. So we got a snail. This is slow. We're not using any caching. Now, if we cache at the browser, we don't even get a network call, right? We saw that, right? So this is going to be super fast, so fast that I don't even have a rabbit on it. Super fast, we cache at the browser. Now let's talk about the CDN. Right, so now the client's going to go to the CDN. It's already cached, so it doesn't have to go to the server. So no snail. We get a nice little rabbit, lickety split. It's a CDN, so it's going to be the server closest to us. This is probably the best we can do. So that's our utopia. These are this is the case we're trying to avoid is the snail, and these are ways to do that. So now how do we drive all that with a cache control header? So first and foremost, just in case people aren't familiar, right? So if here we go, ESPN.com, you go look at your debugger, you're going to see response headers. There's all these things in the header. They're not in the body of the content, right? So the sports news is in the body that ESPN wants to give me. Then there's these headers to do various things. So this is, you got content encoding. It's the same, like it gave it to me in a gzip. My browser knows what to do with that, right? So we got little things that we can control for the browser. Typically it's the browser that we can control via headers. What we're going to talk about is cache control. So in fact, let's just look at this, right? So we got cache control, max age equals 0, and a must revalidate. So that is talking to our browser and telling it some things. And what it's telling, we will get into it. So here's some, I'm going to run through some possible values of this, of that cache control header. So first and foremost, basic, no store. This is simple. This is a cache control header. As I said, don't cache nothing. What happens there? We get our little snail. We hit the CDN. There's nothing there. Go to the server. We snail it up.
So CDN is looking at that cache control value on the header.
Bingo. Yeah. So the server here is returning a header, returning the body, but also returning headers. And in this scenario, it's saying, hey, don't store it. Maybe this content is like very dynamic. Maybe it changes every second. So don't store this. Every time someone asks for it, come to me and we're going to snail it up. It is what it is.
And the server determine how they handle that particular piece of data.
Bingo, bingo. We'll get closer to that towards the end. Here's another example. Max age equals 100. What does this mean? So this is telling the client or the CDN. In this case, I guess it's the client. It's telling it how long you can cache this. This is the max age that this thing can be fresh. After 100 seconds, this is all in seconds, by the way. After 100 seconds, the thing is stale, so you need to come back to me. So what does that look like here? So we got our first request. We're going to get a snail. But in this case, it comes back with the cache control max age 100. So now from time 0 to 100, we're not even going to make a request, because in this one, we're caching at the browser level. So we don't even make a request. Super fast, so fast you don't even get a rabbit. But then at time 101, if you need to come get it, come back to me, because now it's stale. But in that case, we're going to get a snail. Make sense? Let's look at another example. This was the example we saw on the ESPN. Max age equals 0, which means don't ever cache it, because it's going to be fresh for 0 seconds. So it means it's always stale, right? But then we got this must revalidate. So what does that mean? We also have another header here, e-tag. Typically, this is some hash of the content. It's just some hash to say, this is what the content is. And when I want you to revalidate, come back to me, but also provide the e-tag. So when you come, so first request, we get a snail, cache control, must revalidate, but we also get the e-tag. So now the client on the next request, he's going to talk to the server, but give it the e-tag. And then the server is going to do some work and say, oh, I see the e-tag. Nothing's changed. And I'm just going to give you headers. I'm not going to give you a bot. So in theory, this should be a rabbit, because you don't have to build out the whole page. You're just building the headers. So you just do a real quick check. Oh, the e-tag is the same. Nothing's changed. We're good. Just keep doing what you're doing. So what happens is this guy returns, it says, or it returns a header. I forget what header it returns. Or I think it just doesn't return a body, and it says, hey, this is good. Use what you had in your browser cache already. Now, if it's expired, then I'm gonna, we're gonna get our classic snail, because now I gotta rebuild the whole shebang. Now, I do want to point out, I'm assuming a rabbit here, but if it takes forever to validate that e-tag, you're gonna get a snail, right? So this might not be a good scenario if validation requires like 5 calls to a database, right? You had your hand up. So that's max age and the concept of revalidation. And we're going to kind of combine them here. Max age equals 100. But we also want to revalidate. So we're just combining the two concepts, right? We get our snail on the first one for 100 seconds. Don't need to talk to me, because you already got it. Time 101. Send me the e-tag, and I'll tell you whether or not this thing is valid. So the important thing here I want to point out, and the reason why this slide is here, is you start to combine these directives, right? We've got a max age directive and a must revalidate. So this is where complexity comes in, because I've seen some that are like 3 or 4 different directives. You're staring at it like, I have no idea what the hell this thing's going to do. Try making a little graph for it. you're gonna struggle. So this thing can get complicated because, it's caching. Caching is complicated. But you can combine the directives. That's the big key here. So we talked about browser cache. All those examples were browser cache. So let's say I browser cache for like a year. I don't even know if you can go that high, but hypothetically, browser cache for a year. And then, so it's like I have a blog post or something. I browser cache it for a year. And then 2 days later, I'm like, I got a typo. I need to change it. Well, guess what? It's in the browser cache. They're never coming back to you. So you're screwed. So if you got a bug, like forget a typo, right? If you got an actual bug, security hole, anything like that, you're screwed. There's nothing you can do. The way to clear the browser cache is the user. Every browser has a hotkey. I think it's what, Shift Command R on Chrome, and that will like do the request with no browser cache. It'll force it. But if you've got a gazillion customers scattered across, or you can't like text them like, hey, can you Shift Command R? Right. So be conservative when it comes to the browser cache.
I think what I've done in the past, I believe it worked. Maybe it wasn't working, but I would put like script source equals index / main.js or whatever. And then let's say that that's an issue, so we want the new one out. They just put a query string of like x equals like random number, and then that way on the next index HTML. But index HTML needs to be not cached.
Right.
But
So
yeah.
that's a great example. So we've been focusing on server-side rendering. So in a client-side rendering situation, right, where you'll have an index HTML that's very thin, and it's going to load JavaScript and then run the JavaScript to render. So a common thing is like cache the index.html hard because there's nothing there. Who cares? All the logic is in our JavaScript. So then what he's talking about is like you would name the JavaScript file something like fancy, right? Instead of index.js, you would, 1, 2, 3, 4, 5, 6, whatever the hash is.
It's almost like you're putting the e tag inside the file name.
Yeah, that's a great point. Like, you name the JavaScript effectively a hash, aka e tag. And now every time you deploy the JavaScript, it's like the browser thinks it's a whole new file because it is.
Well, you're giving me a little bit too much credit because what you're describing makes a lot more sense. And what I did that later, but what I'm describing, it was just like main.js or whatever. But there was a query string x equals whatever, and then I think because if the query string,
I thought you were so smart.
I did know, but it was only later that
So that's an example of how this manifests from a client side. But like I said, we're focused on server side here. Okay, so let's talk about one more directive. S-MaxAge. I actually looked this up. I found various opinions on what S is supposed to stand for. Server, shared, something else. I'm going to say server because it makes sense with my diagrams. But what do we got here? We got a max age of 0 and then an S max age of 100. So the max age of 0 is talking about the browser cache. So on the browser, don't cache this thing. But at the server, so in our case, CDN, I want you to cache it for 100. So how does that look, right? So we get a call to the CDN, which I guess I should probably put a rabbit there, right? Because to call it CDN, it's the locus, closest server, closest node, that should be fast. But then the CDN needs to go to the server in the first call. We get a snail. We're not caching at the browser, but we are caching at the CDN. So we still get this rabbit because it's super fast to the CDN, but there's no snail here to the server. Time 101, we still go to the CDN. Now we get a snail because we're expired.
So, so this basically gets you out of the problem of dealing with the client's cache. Now you have control over that cache. You've now moved it to the CDN just from that single line change.
Exactly. It's a good call. Now I will say it's as much control as the CDN will give you, right? Like if this is Netlify and I don't have access to Netlify, I might be in the same boat, right? But it's more flexibility than the browser.
Because you can actually bust this cache. You can't.
Exactly. And the key here, though, the cost, everything is a trade-off in this game. The cost is every time we are still going to make a call to the CDN. But it's a trade-off that more than likely is worth it because the CDN is pretty quick. So let's look at our revalidate. So I think for all my examples here, I'm just leaving out the max age because for this section, we care about the CDN. So the same concept as earlier. Now we got a must revalidate. It does the same thing, right? Now instead of the client asking and sending that E tag, now the CDN is sending the E tag. So we still got the same thing. Server is going to look at the E tag. Like if it's fresh, just return with headers. I'm not going to do the whole shebang. And thus we get a wrap. Same concept.
I have a question. Is this CDN really serving much of a purpose at this point? It seems like it's, yeah,
The purpose is what he's talking about. Right? It's
Yeah.
like I got more control.
right.
But it's also like just, it's more complexity, but you have to kind of like opt into that and we're in the future now. And this is cloud compute, so.
True.
I mean,
Yeah,
it's
but
confusing.
you're bringing up a great point, right? You guys, some of y'all are a little more junior, like programming is all about trade-offs. This is a big game of trade-offs, right? So we've added complexity for flexibility because now we can bust our cache. Depending on your scenario, that trade-off might not be worth it, right? So there's another example with the max age of 100, where, so here in the previous one, we didn't even have an arrow here because it was at the browser. Now we're still going to make a call to the CDN. In theory, that should be a rabbit because the CDNs are great. But then after 100, we go back to our E tag thing and the CDN does our validation check. Stale while revalidate. So this one is a little more complicated. As you can see, because I have multiple colors of arrows there. So let's walk through this slowly. So on our first request, standard request, right? Go to CDN, go to the server, we get a snail. The next request, black arrow, we go to the CDN. The CDN is going to start and do two different things. It's going to immediately return to us what we had last time. So it's fast, but it's old because we got the last one. And in the background, this green arrow goes out to the server. It says, hey, give me a new one. So it's doing two things in parallel. So for the client, it's like, here's some old shit, but it's fast, trade-offs. But now I'm gonna go back to the server, give me the new shit, but it's slow.
So then the client would still have to go back to the CDN just to get the new stuff.
So this is a great point. If it all depends on your app, right? Some apps, who cares? There are some apps where it's like, yeah, I'll take the whatever. It's gonna be 9 times out of 10 exactly the same. Or if it's old, like I've been watching the Masters, right? Like you got the
It's like optimistic updates.
Yeah.
yeah, that's a fancy way, academic way. But yeah, so it's like I've been watching the Masters. I'm looking at the score. It's like I'm updating like every 30 seconds. It's like they're not golfing that fast. It's fine. You can give me the thing from 30 seconds ago. Who cares, right?
It's also a shared cache, right? So you might get it as stale, but then someone else goes and gets the new
That's a good
version,
point, right? So this is really good when you have an example of multiple clients. And so like everyone is getting something that's like N-1 old, like you're getting the last one. But depending on the scenario, that might be perfectly fine. But what happens, like again, trade-offs, right? It's old, but everybody gets a rabbit. Nobody gets a snail except the CDN, and we don't care because that's not a unit.
You wouldn't necessarily want this because you don't want the old stuff, because if something happened in the game, you know what I'm saying? Like if it's like sensitive data, like time sensitive data.
Right. Yeah. So in that example where 30 seconds truly matters, like I would not use this if I'm doing like high frequency trading at the stock.
Yeah,
Right?
that's
Where it's like 30 seconds, oh, I just lost $1 million.
Yeah.
Right. But 30 seconds, because they take forever to walk down the golf course.
Oh, I do have one other question. So, okay, so the CDN serves stale data while also sending a call to the server to get new stuff. Does that new stuff show up to the client after that, or does the client has to request it again to get the new stuff? Yeah. So it's not like an automatic. Now you got old stuff. Now here's new stuff.
But you can imagine an app, right? So I'm assuming that like the Masters or whatever.
Yeah, maybe
This
a
probably just
polling
has-
operation.
Yeah, a little
I can get the new
polling.
stuff
Yeah,
in,
yeah. So I'm not sitting there hitting F5, but then again, maybe with the app, like it makes sense. It's like, hey, hit F5 when you want it because maybe it's not that pressing. So again, this game is all about trade-offs, but there's another tool in the tool belt. Okay, So all that was general web stuff. All right, it's like caching basics. This is a remix meetup, so let's talk remix. How does all this manifest in remix? Right. So in remix, for those who aren't aware, like you guys are probably familiar with the loader function, very similar. We have a headers function. This is, I think I stole this from the docs actually. So effectively, you can return the headers. I did get this from the docs because in the docs, it's one of the most common headers that people are probably going to return, cache control. You can make your own, like whatever this strict points thing is, but you can also do a cache control, right? So you can see in this example, we've got a browser cache, 300 seconds. Some, I don't know what the math was, that 6 minutes, 6 minutes at the CDN level. So now, because we have this headers function, we can now start to tweak this a lot easier and start doing all these scenarios that we talked about earlier because of the way Remix does this. Here is an example. I'm trying to remember what I was trying to show here. Oh, right. So let's go back. It's important to call out that in this example, this is a string. It's very static. Every call is going to have the same cache control header. So let's look at this example. I think my use case that I tried to like make up is like, let's say I've got a blog and I publish the blog, but I want to give myself a day to be able to edit it, right? Because it's like I publish it, and then the second I publish it, someone's like, hey, you got like 5 typos in there. Oh shit, okay, let me go fix it, right? So it's like in the day after I publish the post, I might be more likely to update it. So you can see here, here's my loader function, get my post, it's standard stuff, right? Get my post, do some error checking. Maybe I got the publish date. Then here are my headers function. I've got this little utility here. Is that a recent date? So have I published it recently? And then I can do fancy shit. Like say, well, if I publish it recently, only cache it for a minute because I might have made typos. But after, if it's not recent, just cache it for a day, cache it for a year, whatever, right? So now I can be dynamic with my cache control. That is the reason why I can do that is because it's a function. We're going to see this later. Because it's a function, I can do whatever the hell I want. Again, trade-offs, I might do something stupid, but I at least have the possibility to get very fine grain, granular, come up with any use case to affect my cache control. Yeah, this is just me highlighting that one piece. I can, because it's a function, I can do whatever I need to do. Because it's a function. Yes, yes, yes. I did these animations out of order, clearly. I write code, not PowerPoints. So now let's look at another one. Let's look at Next.js. Now that we know how Remix is, so I'm going to start to compare this to other server-side rendered frameworks. How would we do this in Next.js? So this comes from the docs. You set your cache control and the routes. So that the routes have a handler. So for those who aren't familiar with Next.js, and if you are, correct me if I say this wrong, you've got your API folder. So you have your API routes. These are what we would call in Remix resource routes without a component. And then like your UI routes are like in a different folder. It's like they're 2 different things. So what they do is their handler is just like a general function for their API routes. And thus we could do that scenario I talked about, right? With the typo in the post, but it's only for the API routes. You can't do that for your UI routes.
So, I mean, isn't that kind of more fine grained in a way? Because you're,
Could be, yeah.
but at the same time, like doing it in Remix, you kind of have the backstop of just simplifying the problem, saying, okay, we're going to do it by page. Right. And that just kind of makes it just an easier mental model, because this is like, you could do this on like a RESTful API per endpoint and with a client side. But I don't see anyone ever doing that, because it's like a huge pain in the ass to do that much optimization.
It all depends on your use case, right? Like,
Yeah.
just, again, trade-off. So maybe it's worth it, maybe it's not. But the key here when we're comparing these frameworks is with Next, like with Remix, I can do it for anything. I can do it for my resource routes. I could do it for my UI routes. Here, I can only do it for my API routes, AKA source routes. So you're right. It's like they're simplifying
You have to know that going in.
Right.
Yeah.
You simplify the UI routes, which is a good thing because now it's simple. But now we've lost flexibility.
But that's why you put remix.
Well, yeah, this is a remix. All the good things are
No
simple.
bias here at all. What are you talking about? Yeah.
One thing I will call out is if I remember correctly, you can set the headers for a page route, but it's a static, like it's configuration, it's not a function. On the page route, it's just like a static thing. So you still have some flexibility, but not the ultimate function. Flexibility. So again, whether or not this is a good thing or a bad thing depends on the use case. What do we got here? Next. So this is configuration. So it's very similar. I know it looks like a function, but it's not really a function. Because this is like in our config file, it's not in our business logic, right? So I can't make a call to the database and be like, okay, cache control this, cache control that. It's going to be static. It is nice because you can, if you look at that, it's got the 2 stars, right? We got a regex here. So like I could have different static cache control per route. So that's pretty cool. But they are ultimately static. Astro's funny. It's kind of hard to tell here. Admittedly, I'm not an Astro whiz, so I was just staring at the docs. But they have a function to set headers. Right? They're doing a set cookie in their documentation example, but we can obviously just do a cache control header there. But it's just a function. So, and the way it was set up is like it's in the component. So anywhere in the file, I can just run that. So you could totally do that little fancy typo scenario with them. Admittedly, it took me a while to find this in the damn docs. Maybe this is because I'm not an Astro whiz. Remixer just was there. I found it way quicker, but you know, no bias here. What's this one? So this one has a component, which is interesting, which I kind of like. And a component is just the function. So this is effectively a function. So I could do if statements and be real fancy with my cache control. It's an interesting approach to make it a component as opposed to some config or function. But we end up with the same functionality as Remix, so that's kind of cool. Which one is this? SvelteKit. They have like a loader function or something that resembles a loader function. I'm not a SvelteKit expert, but you can see that set headers. So we can do the same thing. So we got the same functionality as Remix here in SvelteKit. So that's pretty cool. So I think it was Solid Start and SvelteKit are the ones that kind of run Astro. Way Astro looked was a little weird, but there are others that kind of have that approach. So that's cool. So this is the quiz. Who here had, before this talk had never really effed with a cache control header? All right, y'all three are gonna be my volunteers. First question, what was your name? First question for Tom. Just give me kind of a description of what you think is happening on GetSpin.com. Backstage equals 0, must revalidate. Kind of describe how that's working. If I got like a Jeopardy,
Oh, well, I mean, you always have to fetch. You must revalidate. You're going to be hitting the CDN. And the CDN will basically handle the caching for you.
are we getting turtles or not turtles? What was it? Snails? Are we getting snails or rabbits?
You might, if the E tag takes too long to parse, because you're passing along the E tag. So on the first go, it'll be a snail, but then the subsequent ones, it'll look at the E tag and then who knows?
Beautiful. You get a piece of slice. What was your name?
You're not gonna get much out of me.
What was your name?
It's Evan.
Evan? All right. I believe in you. I believe in you. GitHub.com. And this is not like internal. This is like the root page. So it's like we haven't logged in. So this is just like the static marketing page. Max age 0, private. I didn't describe private, but take a guess. And then must revalidate.
So I have no idea, but I'm gonna take a guess based on what you're saying. That's gonna give me a snail
Where at?
on the cache control. Because I have to revalidate and it's private.
Right. So the first call is that snail. the subsequent call may or may not be snail based on how long it takes to do the validate. The private is indicating that you should, the browser should only do this, or not just the browser, anybody should only be caching this in a private cache. So I forget
I
what.
think that's just the browser,
Is it
right?
just
So
the
no
browser?
CDNs.
No CDN?
Yeah.
What is that? What is it? Private cache?
Yeah, so only this, whatever this data is, only stored in a private cache, which I think he's right. The only private cache, or the major private cache is the
Like a
browser.
local, a
Yeah,
browser
exactly.
cache?
Yeah,
Yeah.
Oh, so what's a non-private cache?
CDN.
because everybody gets the CDN.
Oh, yeah, basically the domain name. The domain name. It's the differentiation between the private or public cache or.
So remember that slide, we talked about two different types of caches. We got our browser cache
Ah,
and then the CDN, which is the nodes scattered across the world.
okay.
But because they're nodes scattered across the
Yeah.
world, they're public, right? Like
Right.
everyone in Australia is going to hit that Australian node.
Yeah.
So what this is saying, it's like, hey, this is private. Do not put it in that shared Australian cache because this is private to Evan.
Okay.
Well, I have a question. So there's the tag on this and a must validate on this. I'm assuming that even with those two present, that doesn't necessarily mean a CDN needs to get involved, does it?
You're absolutely right.
Yeah.
Absolutely right. Because this is not the SMAX age.
Right.
It's
That's the thing that typically gives it away. If there's an S in front of any of these, then we know for sure a CDN is involved.
for the folks who are more experienced, any thoughts about why GitHub is going private here?
For like crawling, for competing, AI things. No?
It's just sensitive info. It might be a source code that might be up there, you know.
Yeah, I think the reason, and this is all
Organizations.
speculation, is if I'm on GitHub.com, although the root page is mostly just generic, I think like if I'm logged in, I think it's like my data at the top
Yeah.
drop-down or something like that.
Yeah, it's specific to you. You go to github.com, it shows you your repos and everything like that. So that's exactly.
Okay.
You know the root page though? It's not just like a,
Yeah, I thought. well,
that's super interesting. That's what I was thinking too, but if it's, I don't know, that's super interesting. I'll dig into that.
We're all just guessing. No one here works at GitHub.
Okay, fine.
Oh, Seb says.
Steal somebody's shit.
So,
All right, what is, NBA.com. Oh, yeah, this one was interesting.
Oh my gosh. Hold on.
What was your name?
Matt,
Matt, give it a go.
and you gave me everything. Jesus Christ. All right, we have an E tag. We have no cache. We have a max age 0 and no cache, no store. What the heck did no store mean? Oh, there's so many here. I mean, it sounds like, it looks to me like there's just no caching involved at all. So, but like, why is there an E tag in there to begin with? If there's no cache, yeah.
I think a lot of servers just like I think actually Linux, I think. just
Yeah.
Gives the E tag, like it just calculates it for you. So they may not have been consciously doing that E
Yeah, it's like
tag.
a holdover from maybe back when they were or something, and someone forgot to clean up, but okay, I would just say snails everywhere. All the
Yes,
time.
yes, snails everywhere. I don't know, I don't know how many of y'all go to NBA.com, but at the top of NBA.com, they always have the scores.
Mhm.
So I'm assuming that's why, because it's like the score is always gonna change. If it was me, and for the folks who are familiar, you can Scrabble challenge my idea here. It's like, I think they could probably be more fine grained here. Because first and foremost, those scores actually don't change when the games aren't playing. So like 5 a.m, you can cache this bad boy, right? So we could have, if they were using Remix, right, they could have a function. It's like, all right, is a game happening? Okay, no cache. If a game's not happening, cache this until the next game happens.
Yeah.
So that's where Remix can start to now, like throughout the day, their page will be a lot snappier, right? One thing I want to call out is the strict transport security. I had to look that up. This is not cache related. It says max age, but it's like some other thing. What's also interesting is you see a bunch of other like headers here. So I don't know what the hell NBA.com is using for their, it looks like Envoy. I don't know what Envoy is. But
Maybe like another caching strategy.
What's funny is like all of it is like, don't cache,
Yeah.
don't cache.
Yeah.
You really don't want you to
That
cache
homepage is
NBA.com.
very dynamic. Well, yeah, you look it up,
The cache,
headlines and all sorts of stuff.
cache hyphen ability is kind of, looks kind of weird, like to,
Yeah.
Yeah.
you know, like cache ability is
Yeah.
one word. Like,
Oh, yeah.
yeah.
Okay, one more. You got another volunteer?
Okay.
Double.
Mistake. So, okay, so max age of 1. So you got 1. Is it 1 second or millisecond? 1 second. Okay. So there's caching it for a single second. And then it's on cache. What's that server timing? I have no idea what that is.
Yeah, I don't know what that.
But yeah, I guess
That might
it
be
just-
an
you just get a
Nginx.
cache for 1 second.
Yeah,
So,
cache for 1 second. I personally found this interesting
and it's
because
gonna
like,
yeah.
It might be a resource that's used a lot on one page. So like if you have it like, I don't know, like a company's logo, like all over the place, then that way at least. But you know, you at least on the one load of the page, you only have to, you incur one GET request.
Yeah.
But on the next,
makes sense. I was curious, like, why not cache it harder? Like, if I'm doing a search, how often does it change? Maybe it does change.
Yeah.
Like if I search or caching and do the same search 5 seconds ago, will I get different results? Maybe, I don't know. I feel like they could cache harder. if they want to. I don't work at DuckDuckGo. So.
That's true.
Oh, I got another one. Oh, remix.com. So this is the remix page. It's I don't even think the homepage is documentation. It's like very much a marketing website. Another volunteer. I'm calling you Greg.
So, so it looks like, clearly they're using Fly as their server. So that's where they're hosting this thing. And it looks like they've got a little Fly request ID in there, I guess for probably debugging or tracing purposes, somewhere for Fly to take a look at. They don't appear to have a content cache header at all. They do have a rate limit there, which is kind of interesting. That could be something.
IIO specific.
Yeah, I don't know if that's Fly's internal stuff, or I haven't seen one of those before.
I found this shocking. Like that page, I don't think changes. So
Yeah.
if you want to do a PR, y'all could probably cache this bad boy, and make that remix website a little faster. But maybe they have a reason. I don't know.
It's super interesting. Is this like a default caching strategy that kicks in if there's no like nothing here?
Snails all day.
Yeah.
Every
so it is,
request-
it's automatically
Yeah,
defaults
snails
to,
all day.
okay.
Well, that's it for me, gang. Hopefully, like for the folks who had never experienced cache control, hopefully that was educational. And then for those who are a little more experienced with Remix, we got a little comparison. Remix isn't the only one that has this function-based header. But yeah, any questions?
That's good. Why is all the slides on point today? I feel bad. So pretty.
Oh, I just stole these slides from something. Where slides go? Yeah, there you go.
Thanks, Gold.
Right, well, that's it for me, guys.
Yeah, round of
Appreciate it.
applause for sure. Nice. All right, thanks, Kobe. I had to look it up now. Hold on. Oh, not that one. Oh, wait, that's us. Oh, what do we do? Let's see. Are we even caching at all? That is anybody? Oh my gosh, we gotta start caching, everybody.
Okay, so.
No, yeah, go ahead.
Thought experiment, like what should our caching be? So this, like, we can take a look at the site. What is static? What is dynamic?
Maybe some of the next meetup would change, not often, but they would change.
Yep. This is dynamic, so this does update with someone
Yeah.
decides. But I'm gonna be honest, like people aren't jumping on the bandwagon every minute. So we could certainly add a cache header for at least like 5 minutes probably, and that would be pretty valid. So nice. But we're also not getting a ton of hits. So
Yeah.
trade-offs. Yeah, we will get there. Yeah, that's great. That's awesome. Also we're hosted on Cloudflare, which is like pretty fast and everywhere. So
Or I have an idea, you would cache heavily after a meetup occurs, because maybe during that window you would update with the next, then after a week or so, then you can cache longer
yeah,
until the next one. Yeah. Yeah.
that's great. Man, this is fascinating. I got
$50 a year on the bandwidth bill.
Yeah. 50 cents.
That's so surprising. I agree. I totally thought this would have been. What about their docs? Sorry. We gotta look at this, guys. I thought I know they have a cache going on, so it must be like they must be doing a non like caching system, because I know they've talked about like they have like I think I gotta look it up later. They got a whole blog about it.
That one.
Where?
It's the third one.
Oh, you're right. I was looking at a different.
So it's the
No, man,
docs,
that didn't work.
but not the main page.
Oh, I was looking
Oh, and
at the
it's still-
request. Sorry,
still
I
on
got
the-
it. That makes way more sense then. Okay, so for 5 minutes and then, oh, what is 60? I don't know. That's like a year,
It's
I
5
think.
minutes.
Yeah. So that's fascinating. But I think I know they do a system because they actually have like, different versions and whatnot. So if you go on 1.15 and I go to like philosophy, you can change this to, like old versions because they want all those versions to be there. So that's kind of how they're doing it, is they're using the URL in combination with those cache headers, but then they do have a way to like bust it. I'm pretty sure.
That's a
pretty
great
easily.
example of like, they could cache real hard their old version.
Yeah, exactly.
It's like, we're not gonna change.
Yeah, if he's looking at 1.12.0, fine if they are. Yeah.
Cache softly on the new versions.
Yeah, cool. That's awesome. Okay, wow, that was super interesting and fascinating. It was a good segue because I accidentally showed our website. So we do have a website that we're working on. I think there's a little bit of activity that's been going on. I've not been working on it as much as I'd like to, but definitely want to keep working on it because there's cool stuff to do and we have lots of ideas. I think the next big idea that people keep having is Colby's been talking about this, Seth's been talking about this a little bit too, but is the idea of integrating a oh my gosh, forgetting the word. Yeah, blog. Yeah. And like what is that called? What is Sanity?
CMS.
Thank you, a CMS. I just completely blanking on the word. Yeah, integrating potentially a CMS to do some light blogging and allowing for a little bit more community resources. So anyway, if that's interesting to you, just go to GitHub and you can go to remixaustin.com. And there's a couple conversations going on. The one to maybe focus in on is Colby set this one up. There's been a little bit of engagement here, so that's been good. But also if you see bugs and stuff, it's cool. Just put up a PR. It's a good way to get involved outside of the monthly meeting. So I think the last thing we're going to do, I meant to do this at the beginning, but I totally forgot. So Evan, do you want to hop up here really quick? Yeah, so Evan was our sponsor for tonight. So super gracious to bring us drinks and pizza. And I just wanted him to take a second to talk about, oh shoot, wait, what is your company? I'm already
Ronstadt. Ronstadt
That's right.
Technologies.
Ron
So
Technologies.
you'll soon learn why I'm gonna be of no use to you because I'm not a technical guy, but I do play one on TV. So Ronstadt Technologies, if you're unfamiliar, we're a branch of Ronstadt, which is the world's largest recruiting and sourcing company. And Ronstadt Technologies specializes in the IT side of things. So we specialize in hiring contract to hire, and direct hire folks. So I'm here in Austin, obviously. The Austin team is working with like 100 different companies. We have quite a massive national reach. So if you guys know of anybody or are looking for a new job or curious what's out there, that'd be you. Yeah, let's talk. Happy to meet with you guys. I'll have Brooks post my number on the on the meetup link, so you guys can just feel free to text me. Just let me know where you heard from me. And then on the other side of things, if you guys are hiring, we help in that regard too. So above all, just happy to be here and support you guys. Excellent presentations, like even me, who's, like I said, just an acting technical guy. I was able to follow along and kind of get something out of it. So I am paying attention. But I appreciate you guys.
Sweet. Thanks, Evan. Appreciate it. And definitely thank you for the food and drink. And the last thing I wanted to mention is Remix Conf, not EU. Whoops. Remix Conf. Let's see if we can find it. Yeah, there we go. So if you're interested in conferences or you have some like company budget you got to blow or whatever, May 9th through 11th, Remix Conf is happening. Super exciting. I don't have it on me right now, but I can find it for you later. But you can get 25% off through this meetup, which is Nito Cheeto. That's like, I don't remember what that cuts it down to, but it's a little cheaper. We can look at it and someone can do some really quick math for me. What's 700?
Yeah.
Times 0.75. Yeah. So, anyway, but yes, we do have 25% off, and it's gonna be super cool. I will be there. Paul will be there on the big stage.
It's crazy.
Super weird. Yeah, I don't know how
How that happened.
they tricked us. Yeah,
They got tricked.
we tricked them. Sorry,
tricked
into
them.
letting us get on the roster. But it'll be super fun. Also, if you're not able to make it, no big deal. They'll have recordings and whatnot, but it should be super fun. And I imagine they'll release V2 then. I don't know. They keep talking about it, so that'll be cool. But V2, they're like, nothing's really going to change. We're just going to like take flags off of things that are currently listed as unstable. So it'll be cool. But yeah, that's enough of me rambling because I'm kind of directionless at this point. So thanks everyone for coming. Really appreciate it. It's already 8. I'd say stick around, but it's 8. So get out of here. No, but if you want that coupon, talk to me. And if you want to talk to Evan about Randstad, then definitely talk to him. So thanks everyone.